This is our new home in the Pacific Northwest. I've shown it in videos before and I called it a McMansion. And I think that really rings true. It's big, it's grand, and in the fashion of homes built in the 90s like this, it is dumb. Kind of like Jekyll here. Big and D-U-M, dumb, at least by today's standards. I mean, in the 1990s, this probably would have been considered a pretty smart home, actually. It has one of these things, an intercom system capable of communicating with the door, the master bedroom, the spare bedroom, and releasing a door lock that isn't there. The switch for the lights out front can be set on a timer or on a schedule to go on and off when you want. These stairs have these cove lights that'll light up the treads without ruining your night vision. So if you're coming down for a midnight snack, you're not tripping to your death. But of course, tech marches on, and things that are once relevant no longer are. This intercom system does not work anymore. And having this button directly above this button for the doorbell, when we get deliveries, half the time they don't ring the doorbell, and I think it's probably because they're pushing this one on the gold plate that's a little more prominent. I mean, Gregor here is ornamental only. And these stair lights are actually kind of frustrating because if you're trying to head up in the night and they're off, the switch for them is at the top of the stairs. And of course, since this is MandicReally, that's where these 3D printers, the little army of robots, are going to come in and help us with a pile of other tech to smartify this house. I have a couple of notes about this hardware and a tip for you if you're interested in smart home stuff but you haven't pulled the trigger yet. Now, we'll talk about each individual component as we get to it throughout this project, but I purchased all of this myself except for the Pad 7. Big Tree Tech sent that over, so thank you to them. The rest of these items, a couple of them, I got some pretty deep discounts on from my local utility companies. They're incentivizing us to move to smart home stuff so we can better manage and thus reduce our usages of water and electric. So really look into what your utility companies might have on offer, and it might push you over the edge like it did me with this stuff. Our project's going to start here at my server rack as the main hub of this whole new smart home setup, powered with this Big Tree Tech Pad 7. As they say on the box, not only a clipper pad, though I guarantee you 90+% of these are being used as clipper pads. For anybody who's not familiar, Clipper is a firmware operating system that runs 3D printers, and you can run it off of this with a compute module type setup in here. This is a CB1, but we're going to be taking that out for a compute module 4 from Raspberry Pi. Some of you may already be aware of where we're headed with this, but for the rest of you, let me fill you in. The reason we're swapping out the Big Tree Tech CB1 SBC, single board computer, for a Raspberry Pi Compute Module 4 is we're going to be running Home Assistant. This is an open source Linux-based operating system that allows us to tie together a ton of different smart home devices into one platform. It's intended for and runs best on official Raspberry Pi hardware. We're not going to cover installing Home Assistant on this Pi in this video. There's plenty of write-ups and guides on that all over the internet. What we are going to talk about later in the video is the integrations and automations that I set up for the hardware that I'm running, but that's later. For now, I want to get this hardware physically mounted up in my Dell server rack. To help me, I have this video's sponsor, Fadis. They have a range of new products that they just launched that they want you folks to know about. They've got new hot ends, nozzles, and a new extruder assembly. If you have a Bamboo X1 or P1 3D printer, they have the new Conch and Conch Plus hot ends. These have silicon carbide tips on them for the maximum wear resistance. That's a very tough, hard material that's going to wear against the carbon fiber and the glass fibers in your 3D prints very well and stay nice and consistent for hours of printing. The Conch Plus also has their patented end coat coating inside of the heat break for even more wear resistance throughout the feed path. These also feature mechanically stabilized heat breaks. There are 2 screws coming from either side on a bracket that supports the heat break. So if your hot end crashes, you have less likelihood of bending the hot end. And it also means this is serviceable. You can remove that without having to remove the heat sink for clog clearing or replacement. Next up, we have the Opus 2 extruder. This is a 5.8 to 1 gear reduction extruder with a NEMA 14 stepper motor for a compact and a very sleek looking design. This has an internal filament break sensor. So if you run out of filament, it breaks. You have that right right there, no add-ons hanging off the side of your printer, and RNC2 coated gears for high wear resistance and long-term service life. This is designed to keep up with high-flow hot ends, and it's a really clean-looking extruder. Last but most certainly not least, we have the sick nozzle for the Nextruder system. So your Prusa Mark IV or XL. This has the silicone carbide tip as well as the end coat coating in the heat break for that long wear-resistant service life. These are also available for the Unicorn system from Creality, so your K1 series and Ender 3 V3 3D printers. And if you're interested in any of the products we just saw, check out the links in the description to see the new things available from the folks at Fadis. Thank you to them again for sponsoring this video. For our project, we're going to be loading up this PETG CF from AirryOne. It was just the easiest one I could get on short notice, and using that sick Nextruder nozzle in my Prusa Mark IV. Diving back in, the way that I'm going to get this mounted into my server rack is with this 4U blanking plate. This will install into my regular 19-inch server rack, and I'm going to mount the Pad 7 to the face of it. Obviously, that's not very simple. There's no hole in this. So I'm going to create one. Starting as so many of my projects do with one of my favorite tools, blue painter's tape, just to mark the general location of the Pad 7. Now, I jumped into Fusion and designed up my own mounting system for this to mount to the 4U plate. While I was doing that, I also made a template that I can then lay on to this new steel plate, mark out where my holes are going to be drilled and where my hole cutout needs to be for the Pad 7 to pass through this, and then I can start drilling and cutting. A jigsaw is not necessarily the first tool I would go to for this project, but it is the one I currently have available to me as I don't have a compressor in the new studio yet. Then it was over to my Prusa Mark IV with that sick nozzle from Fadis in the machine so we could print this AirryOne PETG CF to make our mounting bracket for the Pad 7 to that blanking plate. This actually installs on the back side of the plate with a couple of M3 screws, and then the Pad 7 presses in from the front and bolts in from the sides to its original kickstand mounting location. I also, while I had filament loaded up, printed a duct that I designed for the CM4 and a 30mm fan to keep it cool. Now, taking up 4 server rack units just for a Raspberry Pi does seem a bit excessive. So I kept the Pad 7 all the way to the side of this blanking plate, so I still have room to mount something else to the other side of the plate. Maybe another Pad 7, another display, something else I could use this space for so it's not solely dedicated to my Home Assistant instance. Now with Home Assistant installed and ready to run, we can focus on the devices we're actually going to be using in here, starting with replacing this dunce of a Honeywell thermostat here. First problem I noticed is the holes for the old thermostat are a wider spacing than the Ecobee thermostat I'm going to be installing in place of it. So I need something to cover those up. Luckily, I can measure fairly quickly and design up a trim piece that I can print on the Prusa Mark IV. This is natural color ASA filament, and it is not fiber filled. This is just plain ASA. But I just wanted to show that that sick nozzle doesn't have to be used on hard fiber filled materials. It can be used on pretty much anything. A little bit of print time later and we have a trim piece to install on the wall that will cover those holes up and then allow us to mount the Ecobee thermostat on top of it and clean up the look a little bit. Ruby has already questioned the look of the trim piece and wants to paint it the same color as the wall, so hey, that's on my future to-do list. Now, I didn't mention why I picked the Ecobee thermostat. The number one reason was my local electric company gave me a big discount on it. I was able to order it directly from them for $30 shipped, which no other thermostat was coming in at that price point that I could set up with Home Assistant. That was the deciding factor. Now, next, I want to deal with the doorbell situation. By the way, if you hear any background noise, this is suburbia, and it is a rule of thumb in this environment that if you want to film something, somebody will be leaf blowing at that exact time. Now we're dealing with an entirely dumb doorbell and an intercom system. The doorbell does work, but the intercom system doesn't. So I'm just going to be eliminating the intercom because I'm going to be installing a Ubiquiti Unify G4 Doorbell Pro. Being part of the Unify Protect system, this is a video doorbell, so it's going to be part of my security camera setup. It's going to be able to detect people coming up to the door, packages being left on the stoop, as well as, of course, just being a doorbell, but also allowing me to talk and converse with whoever is at the door. I did have to do a prep step. My transformer sending voltage to the doorbell was the wrong voltage for the unified doorbell. I had to replace that with a 24 volt unit, but that was pretty straightforward to do. Another prep step was adding this little black box to the inside of my doorbell ringer. This, I believe, not 100%, is a wireless chime control. It wires in line with the original doorbell wiring, and I believe it gets signal from the Doorbell Pro to chime the doorbell. With those prep steps out of the way, it's time to get the doorbell installed on here. I do already know I'm gonna have to 3D print yet another part to make this work out the way I want. Let's get this thing torn apart. With my intercom removed, I have an unpainted spot and this wire hanging out of the wall that I don't 100% know what to do with just yet. That's something we'll talk about later. Then down here with the doorbell switch, I've got a wire sticking out that I actually need and a big hole in here in the siding, which is at an angle and not ideal for mounting my doorbell. So I need to design a part to sit flush on here and get the doorbell to the angle that I want. Realistically, there are probably a bunch of different ways that I could go about doing this, making a mold, a pattern off of it, sketching onto a piece of paper and following the profile of the wall. But I know how I'm intending to approach it, and that's with math, geometry to be specific. So I'm going to lay this flat, straight rule against the peaks of the siding. So it's sitting on the top of there. And then I'll use a pair of calipers, digital calipers, to measure the depth of that peak. In this case, we're looking right at 11 millimeter step to the depth of that. Now I need to measure from peak to peak. I'm looking at 113.28 millimeters from one peak to another. Now I need 3 numbers from a triangle to figure out the rest of the dimensions and the angles of this. I can figure a right angle has 90-degree corner in it, so that's what I'm going to use for my third measurement. I don't even have to measure an angle here. And as a former professional fabricator that had to do this stuff almost daily, Triangle Solver app on my phone is what I use for this. I don't even have to remember a squared plus b squared equals c squared anymore to make this all work. With those measurements in hand, realistically, I don't need to do the math. I can just use the measurements in Fusion to design a side profile view of the siding to create an inverse image of it, the part that's actually going to sit on the face of the siding. Now, while the 3D print for the doorbell is running, I'm going to replace this switch for the front lights of the house. Because this is on the same circuit as the transformer for the doorbell, since I have that breaker kicked off right now, it's a perfect time to replace the switch. This Honeywell switch is fine, but I want to have the ability to set up automations and some other Wi-Fi control capabilities that the switches I'm going to be running through Home Assistant will give me. There are a lot of smart switch options on the market. I decided to go with these TP-Link Topo switches for this application for a couple of reasons. One, this 2-pack was pretty affordable and I needed exactly 2 light switches, one for this front light setup and one for those stair lights I mentioned earlier. The second reason is these are simple switches. There are plenty of smart switches that can control multiple devices, and that could be really useful to have a lot of added functionality in one switch. But I want whoever walks up to this switch to be able to just flip it to turn on the light that they're trying to turn on or whatever they might be trying to power. I don't want them to have to know exactly which button to push in the middle of the night in the dark to turn on a light. And the final reason I went with these is compatibility. They will work with Home Assistant. Now, a lot of products from this brand only work in their ecosystem with their hub and their app. It just so happens that they've started to release some newer products with the newer Matter wireless protocol, which I can use with Home Assistant, and I'll show you a little more of that later. So these will work for me. Now, I'm not an electrician, so I'm not going to tell you much more than swapping this out was as simple as changing a light switch. It is a toggle button, not a flip switch. So you have to push the bottom of it. That took a little bit for me to get used to, but it's simple once you figure it out. While installing those light switches, our 3D print for the doorbell finished up. Again, I printed this in the natural ASA using that sick nozzle from Fadis, and it turned out lovely. I designed this pretty accurately, it turns out, so it's matching to the siding how I was expecting it to. Long term, I probably should seal around some of these old holes with caulk, though this is under an awning, so it's not too big of a deal. Our doorbell wires just hook up to the doorbell and they'll provide power to this. It is a Wi-Fi unit, so that's how it's going to communicate with the rest of my network, which is all Unify hardware from Ubiquiti. So adopting it into the Unify Protect app is very straightforward. The weak signal was a momentary thing. There is one more smart home item that I already have that I want to set up, but I'm not going to do it in this video at this point. It is this Beehive smart sprinkler controller from Orbit. This house does have sprinklers in the lawn and garden, and I've become quite the suburban dad about taking care of the sprinklers more so than the lawn. I really enjoy tinkering with them. This is a smart controller that will allow me to do that from my phone, to cycle things, which would be really handy when I'm trying to find leaks. I can turn it off and on right from the phone and not have to come back into the garage and mess with things. Also, it's going to allow for weather reporting. So if it's going to rain today, there's no reason to run this typical programmed sprinkler run. So this will allow that. The problem is that this is going to mount to that wall back there if it has no drywall on it. So it would be temporarily installed just to then unwire it, take it off when I go to drywall that wall, soon TM. Also, I bought this in the summer. It is now fall, and that means rainy season in the Pacific Northwest, so sprinklers aren't necessary until next summer. There is one more key ingredient missing from our smart homeification here, and that's a way for Home Assistant to communicate with our various smart home devices. Some will automatically be detected by Home Assistant when it's on the same network as those devices. Like our Roomba, Home Assistant is already telling me, hey, it's here, and Ruby's printer. They can both be connected to this setup. But I don't want everything I'm running to be on my Wi-Fi because it would start to bog down and bottleneck the data transmission if every light switch was going through my Wi-Fi router when I want to be sending files to a 3D printer or surfing the internet on my phone. As such, smart home hardware has figured this out. There are different wireless protocols for a lot of smart home devices to use that aren't going to cause traffic jams in your network. Common ones are Z-Wave, Zigbee, and Matter. Matter being the one that my light switches run on, and I have a few other items I know that are going to be running on Z-Wave, not necessarily Zigbee for my applications as it's a little too close to the 2.4 gigahertz Wi-Fi signal. But my Raspberry Pi doesn't natively pick up these signals at all, so these aren't popping up in Home Assistant yet. That's where these come in. It's a USB stick to pick up Z-Wave signals, and this is a little Matter wired gateway. So this one will allow me to pick up both Zigbee and Matter signals, and it's going to wire in with an RJ45 connection to my network. I don't know if these are the best, I don't know if they're even great, or if they're going to work well at all. I just picked some that seemed like they did what I needed them to do, and I believe I checked to make sure they're going to be compatible. Let's find out and get them set up. Installing the Matter gateway is pretty straightforward. It came with a Cat5e cable and a USB-C to A cable to provide it with power, but no power adapter. I had to dig one out for it. I really wish this was PoE powered, but I could not find a Matter gateway that was PoE power. If you know of one, let me know in the comments. I'm gonna get this plugged in. I think I need to add RGB to my rack just so I can film inside of it. So sorry, you're not gonna get to see this. Installation of the Zeus Z-Wave stick. It's just an antenna on a USB stick. It's very easy. I can just plug it into this front USB port here so you folks can see it, but I'm actually gonna plug it into one of the back ports for its long-term use. I'm hoping this doesn't act as a big Faraday cage and block the signal to it. If it does, I'll have to run an extension cable outside of the rack. I'm prepared for that. I'm also prepared to have to do that with the Matter gateway as well, running a longer RJ45 cable to it. After installing my Z-Wave stick and my Matter gateway, I realized there was one piece of connectivity that my whole setup was missing and I actually need, and that is Bluetooth of all things. The Compute Module 4 that I got is an eMMC variant that does not have any wireless connectivity, so no Bluetooth and no Wi-Fi on it. I'm running it over a hardwired Ethernet connection, so I didn't worry about that, but I have a device that needs Bluetooth connection. when I posted to Twitter about this problem, the folks from the official Home Assistant Twitter account actually solved the issue for me. They let me know that there's an approved list of USB Bluetooth dongles, but they also let me know that I can use an ESP32 to act as a Bluetooth dongle for my Home Assistant setup. With the information they provided, I was able to load up this developer board ESP32 with ESP Home Bluetooth bridging firmware. So this is now connected via Wi-Fi back to my Home Assistant setup, but it can be the Bluetooth receiver that I'm missing. So I can actually mount this pretty much anywhere, put it into a 3D printed case I found on Printables, and as long as I got USB power to it, it's good to go. The reason I need that is in this utility closet that I've built here. In a previous video, I installed an AC Infinity blower fan in my HVAC system that I was looking for a better way to control it. Well, Home Assistant is going to be that way, but the communication to that unit is through Bluetooth. So I need to mount up that ESP32 probably on the edge of this closet. It's right next to the server rack, so it doesn't need to be far, to get a good connection to that fan and back to my Home Assistant setup so I can automate things the way that I want. And just as I thought I was done with this, I realized I do have one more thing for my smart homeification here. And that is a extremely important component, a button. This is an Ari, I guess that's how you pronounce it, brand smart button. This can be set up through the Matter communication protocol to do anything you want effectively. It is a blank slate of a product that's going to allow me to set up exactly what functions I want through the press of a button. I believe it also has multi-press, so you could do a different function if you press it a couple of times, and if you hold it for a long time, you can do yet another function as well. I'm only really worried about one press on and off functionality because I'm going to use this as a light switch for these stair lights. That is, however, a little bit of movie magic because that switch isn't working right now. I just pressed a button on my phone. The light switch that controls these is working. This button, not so much. The reason why this isn't currently working is because I don't have a way to connect to Matter devices at the moment. I thought I had that worked out with that Matter gateway that I showed you earlier, but that apparently I cannot get to work with Home Assistant. Found some references online that that's just the way that is. I need to go a different direction. So I'm gonna have to send that back and get a different USB dongle to run Matter devices. So for right now, I just got a switch stuck to the wall. And realistically, that's the power and the peril of smart home tech. If you buy everything from one company, it's gonna work together, but you may be limited by their product line or the options that they have. If you go a route like I am with Home Assistant, where you can set up all these different pieces to work together, you're gonna run into hardware that might not work for you, or things that work today may not work tomorrow. But when you get it working properly, it feels like there's no limit to what you can do. I'm only dipping my toes in. I'm setting up that smart button at the bottom of the steps so I don't have to wire a three-way switch configuration, pulling wire down the steps, across them, to the wall, just so I can get a light switch at the bottom of the steps. I have a wireless button that'll do it. That AC Infinity fan that I was mentioning earlier, I've been running that off of temperature control and it hasn't been ideal. So what I'm going to set up is an automation that when my Ecobee thermostat commands the furnace or the air conditioner to turn on, it'll power on that AC Infinity fan. So it'll be directly tied to the way the HVAC is functioning, the way it really should be. A couple of times throughout this video, I mentioned these intercoms that this house has. They aren't functional, but I'm wondering if I can't repurpose them. My primary thought has been to remove them, see what kind of power is coming to them, and using that to supply power to a tablet or something like that to function as a dashboard for Home Assistant. So that each room that used to have one of these can have its own control panel to control things like the thermostat, the lights in the room, whatever you may want to set up with it. But I also just don't know anything about these things, so I don't know if that's at all feasible. They might be AC voltage, they might have a DC power supply somewhere in the house. If so, I haven't found it anywhere. I don't know whether or not that's a pipe dream to try and do that, and I don't really have any other thoughts on what I can do with them. The one out front that I removed, I'm going to print a small cover to keep the wire there for now and just paint the area where it used to be. And now, thanks to the power of 3D printing, and a bunch of smart home tech, this house is a little bit smarter. A little bit. Half of it doesn't work at this point, but that's beside the point. And thank you again to Phaetus for sponsoring this video. If you want to pick up their new line of silicon carbide nozzles or that new Opus 2 extruder, you can find links in the description to go check those out and get them for yourself. And that is where we're going to call it for this one, folks. Our smart homification project is complete for now. I'm sure plenty of you have some excellent smart home setups out there. If you have any input on what I should do to step up my game, improve my studio and the house, let me know in the comments. That's going to wrap it up for this one, folks. I hope you found this video interesting. Make sure to get subscribed to ensure your 3D prints don't fail. It's not a guarantee, but it can't hurt. See you in the next one.